Hello friends, welcome to Learner's Planet. I welcome you to this session of combustion and flame. This will be our very first theory session for this topic. We'll be discussing about the combustion. What is combustion? What are the reactions taking place when there is a combustion? Also the types of combustion. So let's start our session here. What is a combustion actually? It is a chemical process in which a substance reacts with oxygen producing heat. Right? So when a substance is reacting with oxygen, for example, magnesium ribbon. You must have started this reaction in your previous classes. Magnesium ribbon, when burnt in air, it reacts with oxygen producing magnesium oxide. And of course, lots of energy. And in what form this energy is released? This energy is released in the form of heat and light. So you can say here that the chemical energy, it is converted to heat and light energy. This is what combustion is. Now, substances, they can be classified into combustible and non-combustible, depending on whether they are burnt or not. Say for example, if you lit a matchstick over sand, it will not burn. It will neither produce heat nor produce light. It will not undergo combustion. But if that matchstick is lit and thrown on wood pieces, it will start burning. It means what is a combustible substance? Substance which burn in air to produce heat and light are called combustible substances. For example, wood, it can burn. In this wood, what happens? There are organic compounds. There are compounds which react with oxygen. And they form what? They form their respective oxides. They form, in this case of wood, what happens? Carbon dioxide and water is formed. Right? Water that is evaporated. Water will not be obtained in a liquid state. See, wood consists of compounds. That is, these are called as organic compounds. The chemical compounds which are present in plants and animals. These react with oxygen and they need a slightly higher temperature. Say, wood doesn't start burning of its own only. Have you seen, say, a heap of wood burning of its own? Or finely crushed wood burning of its own? No. It will start burning only after you throw a lit matchstick on it. Or if, this burnt cigarette is thrown on it. So it needs that temperature. It needs a bit high temperature, then it starts burning. These compounds react with oxygen, producing carbon dioxide, carbon monoxide, and even water. Plus lots of energy. This energy is seen in the form of flame and heat. Likewise, coal, charcoal, kerosene, petrol, diesel, liquified petroleum gas, that is LPG, which you get in the cylinders, which is a cooking gas, which is used for cooking, and compressed natural gas, that is CNG, which is used in vehicles. Right? So these are all combustible substances, that is, which burn in air to produce heat and light. And how heat and light is produced? The compounds present in these substances react with oxygen, producing carbon dioxide or carbon monoxide and water, and lots of heat energy is released. See, petrol. Petrol consists of hydrocarbons. See, for example, one of the hydrocarbon is C4H8. When it is ignited in the car, see, there is some ignition given to it. Then what happens? That this reacts with oxygen and it forms carbon dioxide and H2O, that is water. Okay? And the energy. This energy which is released is the chemical energy. This is used by the engine to drive your car. So it means there is a conversion of chemical energy to mechanical energy. Right? So these are all combustible substances. Coal. Coal is burning. It produces heat and light. These are wood, chopped wood. If a lit matchstick is thrown, it will just catch up fire. Kerosene produces light. Likewise, CNG. This is compressed natural gas and it is filled in these cylinders. These cylinders are fitted in the car dickies, and that is dicky of the car. And it is used for the energy released from this gas is used as a mechanical energy, or the energy released while the chemical reaction of this gas within the cylinder and oxygen is converted to mechanical energy. Here see, wood is burned in wood bonfires and fireplaces to produce heat and light. This you must have seen. So it is a combustible substance. Here, the chemical energy which is produced is converted into heat and light energy. Non-combustible substances, the substances that do not burn in air or oxygen to produce heat and light, are called as non-combustible substances. Water, glass, cement, they are all the examples of non-combustible substances. Cement doesn't catch fire. Glass also doesn't catch fire. It doesn't burn and produce heat and light. So these are what? Non-combustible substances. Now, how many types of combustion are there? You must have seen that in some cases instantly you get fire and light. In some cases it explodes, as in the case of crackers. As soon as the cracker is blown or the fire is blown into the cracker, it explodes, causes explosion. This your LPG gas. As soon as you switch on the gas tab and lit with a matchstick, the flame comes. And one is it starts burning of its own. So combustion is divided into three types. First is the rapid combustion. In this type of combustion, large amount of heat and light are released in a very short span of time. Large amount of heat is released. See, for example, LPG, the cylinder. As soon as you just open up the knob and lit it with the help of a lighter or a matchstick, you'll get flame like this. And of course, it will produce heating also. So this is what? This is rapid combustion. Explosion. Combustion in which sudden reaction takes place with the evolution of heat, light and sound. Remember, there is only heat and light in rapid combustion. And see students, the reaction of the combustion remains the same. That is, whatever compound is present inside, they are mainly the carbon compounds. They react with the oxygen and they produce heat and light. In case of crackers, nitrogen oxides are present, due to which it explodes with sound. Right? In LPG, in kerosene, in wood, in charcoal, in petroleum, these, what type of compounds are there? Are carbon compounds. They do not explode. Have you ever seen a petroleum car exploding? If there is a problem, it will definitely explode. But if you after ignition, it is not exploding. But these firecrackers, they explode. With the evolution of heat, light and sound, they contain oxides of nitrogen over there. Barood, which is called in Hindi. And there is large amount of gas is released. That is what is explosion. See, ignition of firecrackers, it leads to explosion. But ignition of LPG gas, it leads to the rapid combustion. It produces the heat and light which can be utilized for some purpose, which can be utilized for cooking. When ignition takes place in the case of petrol, the energy can be utilized by the car to move. But in case of explosion, this energy is waste. You can't use this energy. It's just a fun to lit crackers. That's it. It causes pollution because a large amount of gas is released, and that too obnoxious gases are released because it contains oxides of nitrogen over there. Nitrogen compounds are present over there, right? And it produces sound pollution also. But it's just fun. People burn crackers. Spontaneous combustion. This type of combustion, the type of combustion in which a material suddenly bursts into flames without application of any apparent heat, is called spontaneous combustion. It is just, it itself is suddenly bursting into flames. It's spontaneous combustion of coal dust or white phosphorus. See, white phosphorus, as soon as it is exposed to air, it catches up fire. It is so reactive that when it is exposed to air, it catches fire. That is spontaneous combustion of its own. See, when you are burning or you are using this kerosene or petroleum or wood as a fuel, what is required there is some ignition is required. Some ignition is required. But in case of white phosphorus or coal dust, this ignition is not required. They burn of its own, or it starts burning of its own. So what is this ignition? So there has to be certain temperature at which the combustion starts. If the coal dust is burning, there has to be some temperature. See, if you're burning wood, it means there is certain temperature at which this reaction starts. Otherwise, what will happen? Whatever carbon is present in the atmosphere will combine with oxygen, producing carbon dioxide. The instant reaction, and it will start burning. So carbon dioxide is present in the air. Rest of the things, whatever are present, say wood. Carbon is present in wood, it will instantly combine with oxygen of air and start burning. Does it happen? No, it doesn't happen. Unless or until you lit it or you ignite it, combustion doesn't take place. So there is certain minimum temperature at which the reaction starts. That is the reaction between a substance and oxygen starts. Now that minimum temperature is called as ignition temperature. So let's discuss about the ignition temperature. Before discussing ignition temperature, there are a few important points also which you should know. See, like complete and incomplete combustion. Combustion is simply the reaction of a substance with oxygen producing energy in the form of heat and light and even sound. Now this combustion is again divided into two types, or again is of two types: complete combustion and incomplete combustion. Complete combustion needs a plentiful supply of air so that the elements in the fuel react fully with oxygen. Whatever elements are present in the fuel, if it is an organic fuel, that is the fuel obtained from plants or animals, then it is, say, you obtain fuel from plants, right? So the fuel obtained from plants, that is contains carbon and hydrogen. And that carbon and hydrogen should completely react with oxygen, producing carbon dioxide and water. See, natural gas, petroleum, these contain hydrocarbons. Hydrocarbons are what? Hydrocarbons are compounds of carbon and hydrogen, like CH4, like C2H6, like C3H7 or C3H8. C3H8, right? C3H4. Likewise C4H10. These are all the compounds which are present in the fuel or in the natural gas or petrol. Petrol is basically composed of C4H10. LPG gas is composed of the C4H10 and petrol is composed of octane, that is C8H18. These, they completely react. When they completely react with oxygen, they form carbon dioxide and water. Suppose here there are 8 atoms of carbon. So this 8 atoms, C8H18 plus of oxygen, these all 8 atoms of carbon will react with oxygen, producing 8 molecules of carbon dioxide and 18. Here there should be 9 molecules of water. This is what is complete combustion. And when there is incomplete combustion, what is happening? Large amount of air is available or large amount of oxygen is available. In case of incomplete combustion, what is formed is carbon monoxide. It's not carbon dioxide which is formed. See here, the carbon oxidizes to carbon dioxide and hydrogen oxidizes to water. Water is an oxide of hydrogen. Hydrocarbon plus oxygen gives carbon dioxide and water. This is complete combustion and large amount of air is required for it, so that the compounds or each and every element of that compound is reacting with oxygen, producing oxides. Then what is incomplete combustion? There the complete reaction doesn't take place. Incomplete combustion occurs when the supply of air or oxygen is poor. That is when it is less amount of air or oxygen is supplied or is available. Water is still produced, but carbon monoxide and carbon are produced instead of carbon dioxide. See, hydrocarbon plus oxygen is producing carbon monoxide, carbon and water. You must have seen smoke which is produced when wood is burnt. That is due to carbon. And that smoke which comes when a wood is burnt is also toxic as it contains carbon monoxide. And this carbon monoxide is a poisonous gas. Carbon is released as a soot. And carbon monoxide is a poisonous gas, which is one reason why complete combustion is preferred to incomplete combustion. See, this is wood. This is burning, right? What is happening? This is unburnt volatiles condensed as smoke. Heat is input from here, the moisture output. I have told you that water is produced, but water is produced in the form of vapor. Right? And this is the burning charcoal. And this is the ash. Right? The ash is produced. So in incomplete combustion, carbon monoxide and carbon and water are produced. Carbon is released as a soot. That is that black thing. You can see that black smoke coming out of the wood when it is burnt. And carbon monoxide gas is poisonous. That carbon that gets settled somewhere, that gets settled off at places. And this is the ash which is left behind after all the wood is burnt. That is why gas fires and boilers must be serviced regularly to ensure they do not produce carbon monoxide. In say this is gas fire in which the wood is used. Say if complete combustion will not take place, the soot will be formed, the carbon monoxide will be formed, which is a poisonous gas. So this is what is the difference between complete combustion and incomplete combustion. In case of complete combustion, carbon dioxide and water are formed, and in case of incomplete combustion, carbon monoxide and carbon and water are formed. Right? Now, what are the conditions necessary for combustion? See, it's not always combustion is required because we want energy. We want energy to do work. We want energy to cook our food. We want energy to move from one place to another in a vehicle. So, what are the conditions necessary for combustion? First of all, fuel. A fuel contains the substances or contains the compounds which react with oxygen, producing energy. Or a fuel is a combustible substance. Secondly, oxygen is required. If there is no oxygen, there will be no burning. Combustion will stop. And also the heat. Initially, you need to ignite something. So your LPG gas, as soon as you switch on the knob, it doesn't start to burn of its own. You have to ignite it with a matchstick or with a lighter. So you need some amount of heat for initiating the combustion. Wood doesn't start burning of its own. You need to ignite it with the help of a matchstick. So these are the three conditions which are required for combustion. Combustible substance or fuel, air to supply oxygen, and heat to raise the temperature beyond the ignition temperature. If any of these things is not available, what will happen? There will be no combustion. Except for that white phosphorus which gets burnt of its own. That is spontaneous combustion. Okay. Ignition temperature. What is it? I have told you that a certain minimum amount of heat is required so that the combustion can take place. So every substance has got its ignition temperature. Every substance has got a temperature beyond which it catches up fire. So what is ignition temperature? It is the lowest temperature at which a substance catches fire. Least temperature. So in case of say LPG, it is very less. You just put a light over there, just a spark is required to start the combustion of LPG. Just a spark is required to complete the combustion of petrol, or to initiate the combustion of petrol, not complete. Right? A spark is required to initiate the combustion of alcohol. So what is ignition temperature? Ignition temperature is the least or the lowest temperature at which a substance catches fire. A combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. And the substances which have very low ignition temperature and can easily catch fire with a flame are called as inflammable substances. Right? The substances which can catch fire at a very low temperature, or in which the combustion can start at a very low temperature, are called as inflammable substances. For example, petrol, alcohol, liquefied petroleum gas, etc. In this case, say wood. Wood has a high ignition temperature. Even if it is heated for a little, it will not catch fire. Right? Say it should be, wood is a thing which has got a high ignition temperature. So for a combustion to start, for a thing to catch fire, certain minimum temperature is required which is to be provided. Otherwise, what would happen? Everywhere, everything will start catching fire and it will be difficult for us to survive then. So do remember this, ignition temperature, it is the minimum temperature at which a substance catches fire. So this is all about combustion, students. Now this combustion, when it takes place in case of petrol, when it takes place when it is in car, say when you are using a vehicle, their combustion takes place, it is helpful for us because the chemical energy released or the chemical energy which is released is converted to mechanical energy and it helps us to move. In case of LPG, when the combustion takes place and the flame is produced, in that case also that is helpful because it is producing heat. But if this fire goes uncontrolled, then what? If that energy cannot be utilized and if that energy is causing destruction, then we need to extinguish it. See, this is an example of matchstick, burning of matchstick. How this matchstick burns then? We have started that for a substance to catch fire, a minimum temperature is required. That is the ignition temperature. But in this case, what is happening? We are not heating. We are not putting the matchstick to a higher temperature. What we are doing? Just rubbing the head of the matchstick on the matchbox. How it works? The head of the safety match is made up of antimony trisulfide and potassium chlorate. Do remember this compound. The head of the matchstick is made up of what? Antimony trisulfide and potassium chlorate. The rubbing surface has powdered glass and a little red phosphorus. The rubbing surface. You can't just rub the matchstick on the wall or on the wood or on the floor or on plastic. Anything and it will catch fire. No, it doesn't happen. Because the head is having, say, these things, but it requires this rubbing thing also. It requires red phosphorus also, and there is powdered glass also. Powdered glass is there to provide the roughen or to roughen the surface. So if we use a matchstick for a long time, what happens? The rubbing surface becomes it becomes smooth. Then it becomes difficult to lit a matchstick. Right? So the rubbing surface of the matchbox contains powdered glass and little red phosphorus. When the matches is struck against the rubbing surface, some red phosphorus gets converted into white phosphorus, and we know that white phosphorus catches fire instantaneously or spontaneously. This white phosphorus reacts with potassium chlorate in the match and ignite antimony trisulfide and start the combustion. So these are all the reactions taking place. What happens? When a match is struck against the rubbing surface, the red phosphorus present in the rubbing surface is converted to white phosphorus. See, white phosphorus catches fire instantaneously, or it catches fire spontaneously. It doesn't require any ignition temperature. This phosphorus white reacts with potassium chlorate present over there. And which ignites antimony trisulfide and starts the combustion. And thus the matchstick produces this fire. Right? And wood is of course there, which can burn. So this is all about the combustion. Now I'll be concluding this session, students. I hope you have understood and also enjoyed this session. In the next session, we'll be discussing about extinguishing a fire. And also about the flame. See, this is a flame, this thing. A candle flame. You can see different zones in a candle flame. On the outermost side, you'll find, say, suppose this is a candle flame or a flame of, say, diya, what you call. So there is a blue zone over here. Then there is a yellow one. Then at the center, there is a black zone. So we will be discussing about these zones also. Right? I hope you have enjoyed this session. Just go through your text so that the concept of the complete combustion, incomplete combustion and other things are clear to you. But I hope that after listening the session, the things will be very clear to you. Thank you once again and do have a nice time ahead.